through our research, we found that in order to study tiny things, you need really big machines. Hi, I'm Leanne Williams, and today we try to find out more about nanotechnology and why it's beneficial to study matter on an atomic level.
Well, I think at the beginning one should define what is nano, the nanoscale. The nano, to get it right, is that you take 1 meter, as I mentioned last time, you divide it by 1000, it gives you millimeter. You divide that millimeter by 1000, it gives you micrometer. Up to now, the industry and we were capable to work at that level. But if you take that 1 micrometer, you divide it again by 1000, it gives you the nanometer. It's at that level now that you are capable to work, to manipulate matter, and to make devices. So that is the nanoscale.
The reason why there's a lot of hyperpowered nanotechnology is because, you know, in this day and age, a lot of emphasis is placed on what actually happens at the atomic scale. Now, when we talk about nanoscale, we almost mean atomic scale. Now, a nanometer is 10 to the minus 9 meters, which is a millionth of a millimeter.
I found a very useful definition of what a nanometer is the other day. It's the amount that a man's beard grows from the time he reaches down to pick up his razor and bring it to his face. So that's, it's extremely small.
More or less, you can say it's around 2-3 times the size of an atom. That is how small it is. And we were able to reach this because we have now the tools to observe the matter at that level and to manipulate it.
If we can understand what happens on the atomic scale, we can understand what happens there. And that's why we need this piece of equipment, amongst others, to understand what is actually happening on the atomic scale. It gives us a lot of insight into what will actually happen, what we can expect. This is a gun aperture, this is a condenser aperture, your objective aperture, this is selected area aperture. This is a fluorescent screen. Now, the way it works is the electrons that pass through your specimen. Now your specimen is in this level. That is a specimen through which the electron beam will actually pass. This will basically fit in the tip of this holder, right? Electrons pass through your specimen and they eventually hit the fluorescent screen. Now a fluorescent screen is light sensitive, so light gets emitted when electrons hit it, and then you see an image on there. You can collect a pattern and you can then analyze that and say, oh, okay, that is that particular material that's there. In different modes, you get different magnifications. Like if you talk about in HR10 mode, you go to about maybe 1,000,000 times. But of course, if you're in HR STEM, high resolution STEM, scanning transmission electron microscopy, you can go above 10 million times magnification on this machine.
It was as early as the 70s, 80s, where a theoretician, scientist called Richard Feynman, who predicted that in 2000 we will be able to have the tools and the means to be able to observe an atom and to manipulate it.
So when we talk about nanotechnology, we're talking about basically the research in the sciences where we're actually looking at things at the nanoscale or at the atomic scale.
Just to give a typical idea about how nano affects the properties of the matter. If you take a gold at a bulk, it's yellow. And if you take this gold and you squeeze it up to reach a nanoscale, the color of the gold at that level is no more yellow, it's a red ruby.
Of course, when we talk about nanotechnology, it's more, it's a very wide concept, because now you're talking about anything that's on a very small scale, like small particles, you know. Nanotechnology in paints, in paint coatings, for instance.
Our most recent innovation was a product called Nanotech, and this is using really state-of-the-art type technology that we gleaned from overseas. In a nutshell, it is a product that keeps your walls clean and pristine for a number of years compared to conventional paints that are on the marketplace. And it took us about 2 years to develop this product, so it's not a quick thing that you go through. And through various trials and tribulations, we're now satisfied with the formulation, and that's why we introduced the product only about a month or two ago. Dust and dirt and grime and other pollutants that naturally just float around in the air naturally stick to walls of buildings. And that is where nanotech then really comes into its own. These tiny nanoparticles that are in the film act as photocatalysts when activated by the UV light of the sun. Now, when these particles are activated by the UV light of the sun, they decompose the organic pollutants that stick to the wall. And in so doing, they loosen the dust and the grime that's also sticking to the wall. Now, at the same time, when this reaction takes place, the wall becomes super hydrophilic. In other words, it likes water. Now, these loosened particles that are now sticking to the wall, and when rain and dew come into contact with them, the hydrophilic nature of the wall causes the water to run off in a big sheet, taking all these loose particles and grime with it. The response has been phenomenal. We really are very, very happy with the way that people have responded to the product. As I said earlier, it's a brand new type of technology, and we're having to explain to the people, the consumer, what this technology is all about and how it can benefit them.
Currently, the trend is not to go only to the synthetic systems, but to try to find out what Mother Nature has in the field of nano. The gecko. I mean, it's a really marvelous piece of animal. It's small gecko can indeed, like Spider-Man, go on the walls and the roof. It's really unique. It's a marvelous nano system happening in that with that gecko. So in effect, if you have a gecko on the roof sticking, and if you do just basic calculations, the weight due to the gravitation, and his small or her small tiny feet, it can't be, when you do the calculations, you will find out that it can't stick on the roof. In fact, it does stick. Why? Because in its feet, if you go to zoom, you will find out that it's a forest of tiny spaghettis. And these spaghettis are oriented, as you can imagine. But it's not enough. At the top of these spaghettis, you have like a spatula. And this spatula comes stick. And it's in effect, if you take each spatula, how it sticks is what we call via van der Waals forces. And these van der Waals forces, they are very not significant in, how can I say, in intensity. What happens is that because you have thousands of them, even millions, so they come together, each of them with a small sticky power, but thousands of them are coming on it, And that's how it explains how that gecko sticks. And these fibers are nanoscaled, and the top of it is a nanoscaled spatula. It's a really marvelous piece of work. And again, of course, the community, in particular the space technology-oriented communities or businesses, are really interested in trying to make such a kind of composites which allows you to be as adhesive as the gecko. We are a sunny country. Then over all the year we have more than 50% is just sun. The point is that there are two sectors who do consume huge amount of energy. That is the car industry, transport, and building, the building sector. Quite extensive amount of them is due to air conditioning. Imagine that you have a system which would allow you not to use air conditioning, but to use a smart technology coating these glasses either in a car, the glasses in a car, or in a building. Knowing that such a kind of a smart technology will allow you to regulate the heat from the sun. There is an animal which has that capability. It's the gemsbok. Gemsbok is capable not to drink for days, for weeks, for months. How it does, it controls the heat of its body. When it's surrounded by hot atmosphere, in hot air, what it does, its skin, it's designed in a way that he controls the oxygen consumption, and it does it in a way that it increases the temperature of its skin, so to be sure that the temperature of its skin is always a little bit higher than the surrounding, and therefore it does not how can I say, lose water. It is only the skin. And you know, this consumption of oxygen versus the temperature is reversible. Higher is the temperature, smaller is the consumption of oxygen. And there is a fantastic material which has that property versus the temperature, except instead the consumption of oxygen, it's the optical transmission, the power of that material to allow the infrared radiation to come through or to be stopped. And that material, in effect, is the vanadium dioxide. And South Africa, it happens, is with China, the number one who produce, from mining sector point of view, this material.
In studio with us today, we have two master students in the field of nanotechnology, and that's Olushula and Nomsa. Olushula, hello and welcome to the show.
Thank you very much. And
how are you doing? I'm very good, thank you. Nomsa, how are you?
I'm fine. How are you?
That's great. I'm very well, thank you. Now, my very first question goes to you. Why were you interested in going into the field of science?
My interest started when I was in high school from my high school teachers. I've always found chemistry specifically to be easy, so that is why I was interested in it. So that is how I found myself in the field of science.
Wonderful. Olushula, why the interest in nanotechnology?
Ooh, okay. While I was still in high school, I found out that my two strongest subjects were actually chemistry and biology. And over the years, after my undergrad, where I did industrial chemistry, I found out that I could actually take up the next available opportunity. And finding myself in South Africa, I was introduced to nanotechnology by my supervisor, Dr. Leslie Patrick.
Wonderful. Nomsa, why do you think that research in nanotechnology is so exciting at the moment?
It's very exciting because nanotechnology, basically, it gives us the opportunity to solve problems that we couldn't before. I mean, in our field specifically, water treatment, several methods have been used, like adsorption, chlorination to treat water. So what nanotechnology basically is doing, it's giving us the opportunity to look at other ways of trying to clean water in a cheaper, less expensive, I don't know, just new ways of doing things. Yeah.
Now, I'm so fascinated by nanotechnology, but what are the responses of people when you tell them what you're studying?
The public, basically, they're not really aware of nanotechnology. So I think nano programs need to be put in high schools, or for kids to start up with them in primary schools. And in that way, if the kids are aware of what nanotechnology is, then generally the parents will also know what nano is. And in that way, the public will be able to be aware. So.
Wonderful. Olusola, are there any exciting projects that you've been working on?
Yes, nanotechnology generally is exciting, and basically I'm working on hydrogen separation and purification using a composite membrane, polymer metal composite membrane. Now the idea of my project is a build-up or a thin film deposition of a metal on a polymer substrate for the purpose of hydrogen separation and purification. Now the significance of my project is trying to beneficiate South Africa's vast resources in form of coal and platinum group metal. And to a large extent, I think it's been rewarding and interesting and very, very prospective.
Wonderful. Now, when I think of scientists, I think of a very isolated career. Is that the case, or do you work in a team as well?
Oh, interestingly, the group that I belong to, that's the Environmental and Nanoscience group in the University of the Western Cape, under the leadership of Dr. Leslie Patrick. I think we've decided to build a home away from home, because we relate and interact together as one. It's not a situation of just doing the lab thing always. I mean, we create forum for us to share ideas, to discuss what our challenges are, what are, the problems we're facing in the lab and the rest of them. And this actually comes in form of weekly presentation that we do, where your colleagues can give suggestions on some things you can do, and you have a sense of belonging, that you're not actually left alone to do all the rigors of experiment and data interpretations.
That's wonderful. Wow, it's opened up a new world for me as well. Nomso, what are the job opportunities or the career opportunities available to students who have just completed a degree in this field?
There are a lot of things that you can do, but mostly you go into the research field, where you start up a research career, or you can do masters, PhD, or you can even after that go on and work in industry. I mean, there are a lot of things that you can do, basically. It just depends on you, the person, what your ultimate goal is. Because some finish their degrees and then go straight into the law field, they become patent lawyers. So there are a lot of things that you can do.
Okay. And what are the subjects that students or matriculants or students in school, when they're choosing their subjects, what are the subjects that they would need to have in order to eventually study in this field?
Basically, you need to be someone who's a maths, physics, biology student. Not that you need to excel in them, but at least you need to be good in them. So
and it's
those
very
are
specific. They have to have mathematics.
Maths and physics,
Okay.
yes, you have to have them.
Wonderful.
So those are the subjects that you really need.
Olusola, what are some of the most rewarding experiences in your studies so far?
Trust me, there's no scientist that will tell you any moment is rewarding until you get some interesting results from your experiment. And because the idea of carrying out the experiment in the laboratory is for you to get some wonderful results. So when you carry out those experiments and you have results that are very wonderful, then it becomes rewarding that after all, the moments or the time you spent in the lab is not wasteful. As for me, my project has been challenging, but the results have been so impressive so far.
Wonderful. And give us a description of a day in your life. What activities do you do, and what do you enjoy the most, and why?
Oh, okay. An average day in my life has, it's a form of triangle. Okay. I mean, from the hostel to the lab to the library. I mean, the only time we try to, or I try to look for fun is maybe just creating one for myself, and it's not so often. It's not so often.
And Nomso, what in your opinion is your day like as well? I mean, is it pretty much the same as Olushola's day? Is a little bit of excitement there?
Well, mine doesn't really include the library, but yeah, the lab in the office, that is my day.
Wonderful. And Olushola, in your opinion, how can South Africa benefit from this field of nanotechnology?
South Africa has got a very wonderful and strong structure for nanotechnology. I think, for instance, I am privileged to be on the board of the South African Nanoscience Initiative, the executive chapter. And it's been so interesting seeing the number of students that are working on nano-related projects. And it tells me something that South Africa is on the right path as far as nanotechnology is concerned, because you see, the idea of nanotechnology is it's multidisciplinary, it's all-encompassing, it cuts across all areas of science. I mean, it's applicable in all areas of science. So you see so many students working on different projects, but that are nano-related. So South Africa has been, I mean, as of now, on the right path towards achieving a very strong base for nanotechnology. And I remember last year we had the South African Nano Summer School, which was coordinated and organized by the DST and in conjunction with University of the Western Cape. And yeah, we had participants from India, from Argentina, and it was really interesting. It was really interesting.
Wonderful. And just to end off with Nomso, what advice could you give our viewers out there who are looking to go into a career in nanotechnology?
Any advice that I can give is that you just need to be someone who really can work hard. That's how science is. You won't get rich. It's not a field where you get rich quickly or you make a lot of money, but it's rewarding in the sense that you come up with new things that can help people. So you need to be someone who wants to do something for the public if you want to go into nanotechnology. So that's the only thing I can say.
Wonderful. Thank you so much for joining us today. It's been very, very interesting. And I know everybody that's been watching has learned a lot as well. Thank you so much.
Thank you.
Thank you.
Well, it's apparent that the field of nanotechnology will be making great strides in many areas of our lives. I personally can't wait to hear more on this interesting subject. But that's all we have time for today. Till next time, take care.